Welcome to 4.3. Now, we are going to be talking about slopes. Now, a slope has several different meanings and several different symbols that you are going to be aware of. And you're going to be needing them as we move forward. Now, we're going to also have to understand the formula and how to find the slope when we're given 2 points. And of course, we've got an application problem, but I'm pretty nice in this particular PowerPoint because I did a lot of the work already and I typed it in. I'll just explain it to you. And then you got to remember about these two graphs that we just did. Remember the horizontal line and the vertical line? Okay, hopefully you remember. In the formula, AX plus BY equals C, what's going to be missing? What are you going to have a vertical line missing in this equation? And then we're going to be given a slope and a point and have to graph. And this concept is going to be used throughout the remainder of the course and in through 482. This is what we call graphing using a slope and a point. And as I said, we're going to go 3 points. Okay, and you're going to find out why. And this is one of the reasons why I like 3. Now, general information. Now, I want you to know that there are 4 types of slopes to be graphed. What's happening is this is the negative end, and we're going to the positive end, which means we have a positive slope. Now, if we start at the top and go down, we have a negative slope. And then remember, we have the horizontal line, which is saying 0x plus y is equal to c. This term is missing. In this one, we have x plus 0y is equal to c. This term is missing. We don't have y values. Okay. And you're also going to hear them talk about steepness, or there's something called rate of change. And that is also known as a slope. Because if you remember in earlier, what was a rate? A rate is a fraction. A slope is a fraction. And let's prove it to you. Okay, this cursive M is known as the symbol for slope. But if you look across the board or my slide here, notice that I have fractions here. Okay. This is known as rise over run. The rise is going to be your up-down number, and that's normally your numerator of your fraction. And the run is normally your denominator of your fraction. So a slope is a rate, and a rate is a fraction. Isn't that nice to know? Now, these are formulas for a slope. This is how we algebraically determine the slope. Now, the other definition of rise over run is the change in y's over the change in x's. Now, this delta symbol over delta x is a math symbol that comes later on, but it means vertical changes in y, horizontal changes in x. So these last two over here, we're not going to see as much, but we will see the rise over run, and we're going to see the formulas. Now, let me show you what I mean. Okay, this is the slope shown on this picture. Now, I want you to notice the blue. The blue is known as the rise. From this point, I'm going up 3, which makes this a positive 3. Notice I'm starting down here at this point, and I'm going up to this point. Well, how do I get it? Well, I go up 3, and I go right 5, or I run 5. If I go right, it's positive. Now, notice I started with this point. Well, I want to give you a little catch. What happens if I want to go the other way? That means I want to start from here. Well, I want you to notice something. I want to go over to -2, -1. Well, this time, watch what happens. I'm going to go down 3, which means my slope is negative. And from this point, I go left. I went down and I went left. Left is negative. Now look at my green fraction and my blue fraction. A positive divided by a positive makes it a positive slope. But if I have a negative divided by a negative, isn't that also positive? Yes. This concept is saying when I go from one point to the other, does it matter whether I start with -2, -1, and go to 3, 2? Or can I start from 3, 2 and go back down the line? The answer is yes. And this concept of slope, when you graph, is going to be real important. And you're going to notice that we use 2 slopes because one is taking us to the right, but the other is taking us to the left. Okay, and let me show you what I mean. Okay, now you're given this number 4, and you're told 4 is a slope. But you have to remember, a slope is a fraction because it is a rate. And a rate is a fraction. which makes slope a fraction. So we put this 1 underneath it. Well, I have 2 points here. I have 1, 2, 2, 6. Now, the easiest point is I start right here with my orange dot. I'm going up 4, which makes this a positive 4. And I'm going right 1. But remember, I can actually go backwards. I can start at 2, 6 and go down 4, which makes this a negative 4. But then I go left, which is negative 1. 2 negatives make a positive. 2 positives make a positive. 2 negatives make a positive. So does it matter whether I start with the orange or the green? No. But I have to be able to understand that my first number is my up-down number. My second one is my right-left number. Okay? So my vertical change is my up-down number. My horizontal change is my right-left number. I've got to keep that in mind. That is what slope means. And here's one that's going to show you something. Okay. The important ways to know that a slope can look and read differently. Okay. This is my slope. Do you see I have a negative with it? Okay. The negative is written with the fraction bar. But you have to know that I can bring that negative to the numerator and make 5 positive. And if you think about it, a negative numerator and a positive denominator still makes a negative fraction. Well, I could do the opposite. I can move that negative to the denominator. But that means I'm making the numerator positive. Well, a positive numerator and a negative denominator still makes my slope negative. And as you see, this time I'm starting with point A. How do I get to B? I am going down because it's negative. And I'm going right to get over to that point. But remember, I can do the very opposite. I can start with B. But that means I'm going up 3, left 5, up 3, left 5 is that fraction. They can look different, but they're still the same line. This black line that I'll make orange here, am I going up the stairs or down the stairs? That's what we got to look at. Okay. And graphing, this becomes real important. Okay. And then these should be very simple. Okay, this has a slope of 0. And you're going to say, why? The AX term is missing. This is a slope of 0. A horizontal line is a slope of 0. Now, my vertical line, okay, this is BY missing, okay? BY is missing. Now, this is where you got to be careful. The slope is undefined. Do not tell me the word impossible. Do not tell me it cannot be done. It has a specific word because you are dividing by 0. And we're going to show you why it's undefined. But this is either known or unknown. And we're going to show you how to prove it. Okay, we want to read the graph to determine the slope. Okay, you have 2 points. Now I'm going to call this A and this B. Okay, so my slope, which is this cursive M, now notice what I'm going to do. I'm going from A to B. I'm going from A to B. Now this is A to B. That means I'm going up 2, which means this is a positive 2. And then I'm going 1, 2, 3, 4, 5, 6. I'm going right 6. Now, there's something about this slope you got to know. This is a fraction. Can I reduce it? Yes, I can. And you're going to say, well, why would I reduce it? Because there is a hidden point in here. And I'm going to show you right here. You see where it crosses the line? How do I get to that red place? I'd go up 1, right 3. Isn't that this fraction reduced? Up 1, right 3. They're going to give you 2 points, but fractions must be reduced. Now, I'm going to erase this for a minute. Okay, notice we went up 2, right 6. We went from A to B. Now, notice what I'm going to do here. I am going to go from B to A. Write this up here so I have space. Okay, this is my cursive M. Now, I'm going from B to A. Now, I've got to go up, down first, which means I'm going down 2. That's -2. And then I'm going left 6. Well, when you reduce this fraction, doesn't it still give me a positive 1/3? Yes. When you have 2 points on a graph, or you have a line on a graph, you can read the slope a lot quicker than you can do it algebraically. But you have to be able to know that you can go from A to B or B to A, and you're going to get the same answer. That's the beautiful part about slope. Well, let's try one more. Okay, now I do want to tell you that sometimes they're just going to give you a line and they don't always give you 2 points. But I think Alex has been better in that we've tried to get them to give us the dots, but sometimes they don't. If you have to make your own dots, make sure that you make them in a place that's easy to read. Like those two are right so that they're like the intersection of a vertical and a horizontal line. They're not between, they're right where the vertical and the horizontal lines meet. Now, I'm going to call this point A, and I'm going to call this guy B. Okay, my slope. Okay, rise means up or down. Okay, which means from A, I'm going straight down. 1, 2, 3, 4. I went down 4. Okay, so this is down 4. I then am going to go right 1. Now, right is positive. Now, this fraction, -4/1, is going to become the whole number, -4. Huh? And this is going from A to B. Let's try it again. Huh? This was A to B. Well, let's do B to A. Here's my slope. Okay, you go up, down first. Well, in this case, I'm going up 4. It's a positive 4. But this time, I'm going left 1. A positive 4 and a -1. Doesn't matter which way I went. But I have to remember, I go up, down first, not right or left. You must go up, down first. When finding a slope on a graph, you first must go up or down, then you go right or left. And that's the part that people forget. You go first up or down, then you go left or right. Okay? Now, this is how you look at a graph, and this is going to become important to us. Okay? Now, this is where you're going to be doing it algebraically. Now, this is where I like to do this. I know that my slope formula is going to be y2 minus y1 over x2 minus x1. And if you want to go all the way back to here, okay, notice that I'm using this formula. But can you switch them around? Yeah, you can do y1 minus y2, x1 minus x2, and you could understand that because when, remember, we get two different slopes, but they equal the same number. I like this formula, but here's what I do with the formula. See where the 5 and the 8 is? I write below them x1, y1. Then I write 4, 7 is x2, y2. This helps me put the numbers in the right place. Now, the 7 is my y2. Now be careful. This minus is part of the formula. And then I have my y1, which is 8, over x2 is 4, minus, that's part of the formula, x1, which is 5. Okay. 7 minus 8 is -1. 4 minus 5 is -1. Negative divided by negative means my slope is a positive 1. Huh? And if we did the opposite, it would have been 8 minus 7, positive 1. 5 minus 4, which is positive 1. I still get the same slope, positive 1. Let's try again. Okay, my slope is y2 minus y sub 1 over x sub 2 minus x sub 1. Now notice order matters. And why? This is x sub 1, y sub 1. This is x sub 2, y sub 2. Now, this is where you're going to have to be real careful with these negative signs because they're part of the formula. You can't get rid of them, which means right here, this y2 is this value. So this is 2. But remember, I have my negative value here. But look at my y1 value. This is a negative 5. That yellow negative you can't get rid of. Okay? And then I have x2. Well, x2 happens to be my green, which is -7. But remember, I still have my negative value here. And then I have x1 right here. This is -2. This is where you have to be careful. This is going to give me 2 plus 5 or 7. This is going to give me a -7 plus 2 or a -5. Now, this is where you have to realize the slope can be written negative with the fraction bar, 7/5, but it can also be written -7 over +5, or it can be written 7 over -5. I will be honest, Alex, when you do this homework, wants the negative with the fraction bar. And when you look at your answer choices, the reason they put it with the fraction bar is you don't know where the negatives comes from. Is it in the numerator or is it in the denominator? You don't know. But one of those numbers have to be negative. One has to be positive. Now, this is where we're going to look at this one. Now, this is saying I want a slope. This is y2 minus y1 over x2 minus x1. Okay, x1, y1, x2, y2. Okay, and I want to show you something. Do you see that this y value is 2 and this y value is 2? Okay. Well, this is going to give me my slope of 2 minus 2 over 1 minus a minus, because notice this has got a negative. Notice how I put it in parentheses? Because this is 0 over +6. Now, this fraction is for a vertical line. The slope is 0 because my y values, take that back, should be, this is the horizontal line. I knew what it looked like, I just couldn't do anything, okay? Because if you think about it, 0 is your up-down number. Well, if you're not going up or down, you're only going right or left. So this is a confirmation of our horizontal line. Do you see my y values are the same? Now, let's try it again, except this time, notice this value and this value are the same. My slope is y2 minus y1 over x2 minus x1. Well, this is x1 y1, x2, y2. Well, this is going to give me 5 minus, because remember, I can't lose this minus, but this value I'm putting in parentheses, -3. I don't want to lose this negative sign. But the bottom is -1 minus a -1. Again, I don't want to lose these negative signs. Now, notice what happens. The numerator is going to give me a +8, but a -1 plus 1 is 0. This is my vertical line. And my slope is the word undefined. And notice what's missing. Notice my x values are the same, but my y values are different. Okay. Now, I got 2 more to do. And this is x1, y1, x2, y2. Now, I'm just going to write the fact that I remember the formula is y2 minus, now, this 3, you could either put in parentheses, but since it's positive, we know that 3 is going to become negative. And then we have 5 minus 2. Well, this is -4 over +3. Now, do not make this a mixed number. A slope is a fraction. Slope is a fraction. So that means that my slope can be written -4/3. But remember, it could be -4 over 3 or 4 over -3. Alex likes this one, putting the fraction bar, the negative sign at the fraction bar, because you don't know where the negative is going to appear. Okay? Now, the last one I always do, because some of you may not like my lovely numbers, but I think they're really good. Okay. Look at these. They are fractions. Oh, I can tell you're excited. Okay. Now, this is x1, y1, x2, y2. Now, my slope is y2, which is 3/2 minus y1, which is 1/2. Look at this. Same denominators in my numerator. Well, I'm going to let you know if they're not. You're going to have to make them the same. But this will give me 2 over 2 in my numerator, or the number what? My denominator is x2, which is 4/3 minus 2/3. Now, this is going to give me 2/3. Now, this is something that you may forget. This is called a complex fraction. I can't have that. I have to know, what does that line mean? It means 1 divided by 2/3. And remember, we flip this one. This is 1 over 1 times 3/2, or 3/2 is my slope. You cannot leave it as a complex fraction. This line means divide. You've got to come over here and do the divide, which means my slope is 3/2. Okay, the last we're going to do here is graphing. Okay, this is where you're going to learn to use this slope. Now, the first thing you're going to do is graph the point. Well, this is going to give me from 0 a +1 down to 3. We graph the point. Now, from the point, use the slope. Now, that's where you have to know that this top number is your up-down number. So that means from this blue dot, I'm going up 1, and your bottom number is your right-left number. So that means we're going up 1, right 2. Right there. Right 2. But remember, we just went up and right, and that took us in this direction. But I've got to go the other direction. Because remember, down 1 is -1. Left 2 is still the fraction +1/2. So down 1, left 2. And you're going to notice I have 3 points on my graph. I have this one, I have the blue dot, and I have this one. 3 points. It makes a better line. It's more stable. You've got to use this slope. If you go up and right, you go back to the blue dot and you do the opposite. You do left, you do down, and then left. Okay. Now you're going to say, well, why? Doesn't 2 points make a line? The answer is yes. But you're going to find as we go further and further, if you can't go in the 2 directions, you're not going to be able to really draw a straight line, especially with Alex. You've got to be able to know that a +1 over a +2 is the same fraction as -1 over -2. Okay? Now we're going to try it again. Graph that point. 0, 2. That's right there. That's my green dot. Now my slope. Okay, I have a -3. I'm going to put a +1 below it, which means I'm going down 3, right 1. Down 3, right 1. Now notice it's sending me downward, but I need to go in the opposite direction. Well, if I go down and right, what's the opposite of down and right? Up over left, which is a +3 over -1. 1, 2, 3. Look at my red dot. This was my up 3, left 1. A blue, green, and red dot. I know you may not like this, but with Alex, it's very important that you have 3 points, and how you get them is going to be better when you have 3, not just 2, 3. Okay? Now, the next several slides are mostly for your information because some of you are going to have story problems that deal with what I'm going to talk about, and some of you are not. Some of you are going to have the first story problem and not the second. Some of you will not have the first story problem, but you may have the second one. And it's better to just show you what I'm talking about than to do all the math. Now, you're going to be given this picture. And this is an application of slope. Now remember, slope is a fraction. If you're told that an incline, and that's what this is considered an incline. Okay. A sign along the highway through the Rocky Mountains is shown on the right. What does it mean? Okay, 7%. You've got to make it into a fraction because a slope is a fraction. The slope of the road is 7 over 100. The fraction. Now, what does it mean? The 7 is your vertical. Your 100 is the horizontal. And here comes the words. The top number, the 7, is your rise. The highway rises 7 feet for every 100 feet. The 100 feet is your run. So as they're driving along this road, we are going up an incline at 7 feet for every 100 feet those tires turn. That's what this sign is saying. That is what this slope is meaning. Now, this is one story problem. The percent becomes a fraction. That fraction is using rise over run, which was the very definition that we talked about way back when in the early slides. And notice they use the word rise. because that's what the top number means. Now, here's an application. Now, I chose this one because it makes it kind of easy. But this time, they're using the years. Remember before we didn't use the years? We said X after 2013. Well, here, you're not going to see that in this story problem. It says the graph models the number of members in a certain club from 2015 to 2019. Okay, now, some of this we're going to do in the future, but it's reading this graph. This is not giving us the 0, 1, 2, 3, 4. It is giving us 2015, 17, and 19. Because the phrase X is the number of years, and notice the phrase, there is nothing that says after something. So notice the difference between the story problems. Now, we're reading this graph. How many members did the club have in 2015? It had 358 members. That's the member number. And notice number, members. 215, which is my X, is the year. Now, 2019 had 610 members. Very easy to read. Now, what does the sign of the slope of the line? Now, what does the sign? Well, that means to go from 358 to 210, we are going up, which means our slope is positive. That's what they're asking you for. What does the sign of the slope of the line segment mean? It means it's going up. It's increasing. Now notice all the words that mean positive. Going up, increasing, going up. Now, find the slope of the line. Okay, well, the slope is going to be what we're going to do next, and I'm going to show you how to do this. We're taking this point and this point, and we're going to answer C on the next slide. Okay, this was 2015, 358. This was 2019, 610. Now notice what I'm going to do. X1, Y1, X2, Y2, X2, or Y2, Y1, X2, X1. And remember, reduce. And as we just saw, the slope was positive. It's increasing. And what does this slope mean? Right here. The number of members of the health club increased. Notice we use increased by 63 members per year between 2017 and 2019. Now, it's easier to give you this so that you can kind of read it over and think a little bit about it. But this is how we get the slope. Remember how I did x1, y1 on the points that we did to algebraically determine the slope? Well, that's what I did here. Well, this is going to end my lovely, yay, section here. So if you have any questions, feel free to ask me. Yay! Oh, I gotta wait for my computer to come up. So have a good day. It is so good to see you back, and I hope you're loving my lovely, lovely experience here, because I am going to sign off. Ooh, let's open this up. Okay. Okay. Gotta hit the right button here. There. Okay. See you then.